In this video, we will see how to use the buzzer to emit a fixed sound or to produce sounds with different frequencies. When using a buzzer, the first thing we need to ask ourselves is whether the buzzer is passive or active. From the top view, the active and passive buzzers are practically identical. Both when powered on the positive pole with a positive voltage, for example, with the digital output of one of the Arduino pins, such as 5V, and with the negative to ground. Obviously, we will hear a fixed sound with a fixed frequency, but only the passive one allows us to change the devices. And you can see it on the left one. It is open, not sealed, with the PCB visible, and thus the green edge with the soldering here. This is the passive one. The passive one is capable of being powered here with a square wave function with variable frequency, and therefore the sound emitted has a different frequency. So to emit different sounds, it will be enough to use a basic Arduino function called tone, passing it the frequency value, and the small device will emit that frequency. Instead, using the active one, the only result we can achieve is to emit a sound. We can make it intermittent and, of course, decide when it will be emitted, but always at the same frequency. The sound will be heard. So the fundamental differences are that the passive one can emit different frequencies. And so we won't just use a simple digital signal which is 0 or 5 volts. We will send a function with different frequencies to hear different sounds. In the case of the active one, however, we will simply use an on-off type circuit to hear the sound. Let's quickly see at the circuit level how we can use the buzzer. If we search for a buzzer among the components on Tinkercad, we find only one. This works both as active and passive. Obviously, it's a simulator and doesn't physically distinguish the two types. So if we use a digitalWrite, we hear a single sound. If we use the tone function, we will hear different frequencies. Let's immediately proceed to distribute, to place all the components we need. So the resistor. To light up an LED, just to confirm, no? That we are powering the device LED and the buzzer. So here we place an LED that will light up along with the sound of the buzzer key. We take a button to activate the sound and a resistor to place. To set a reference potential. To use the button correctly. So with the components arranged, we first connect the ground on our breadboard. Then we ground the cathode of the LED. We ground the one end of the resistor. And we ground the negative of the buzzer. We bring the power supply to the breadboard as well. And use these 5 volts to have a high voltage from one side of the button, which we will then transfer to Arduino to communicate that we want to turn on the LED and thus the buzzer. We decide on 2 pins to power the buzzer and LED simultaneously. So for example, we can use pin number 8 and carefully bring this state to the red line at the top part of the breadboard, gently and precisely. So we take as the button input. The pin, for example, 7. So what do we need to accomplish? We need to create a code that listens to the state of pin number 7, which is controlled by the button press. So when I press the button, it transfers 5 times to the other side. Using digitalRead, which is the function that reads the state of the digital pin, we will understand if the button is pressed, and if the button is pressed, we will set the state of pin number 8 to high, using digitalWrite, of course. Distributing the red along this line. If we want to power up with both the LED and the buzzer, we just need to add these 2 connections and we will find ourselves in the state. High both the more positive pin of the buzzer and the anode through the LED's resistor. As for the code, first of all, I would use define to decide. To declare, so define 8 output We call it output. Pin 8, which is the one that powers the devices. Let's call the button number 7, which is the pin. We will read it to understand the button state. So in the setup, the only thing we will put is the pin mode, to define that pin 8 communicates with the board. That the pin mode, that pin 8 is used as output while the button is 7 is obviously an input. As for the loop, the only thing we will do in the loop is to go and check. If we are pressing the button. So who is the subject of the if is the state of the button. How do I read it? Simply using a digital read. Pin, to which the button is connected, so what we have called button, which is pin number 7. What do we do? If it is pressed, we will set it to high state. Output. So if we are pressing the button, the output will be set high, otherwise we set it low. We thoroughly check the code for any errors, even just spelling errors, carefully copy the code and put it into the simulator. And then we verify the code by clicking the button. So by clicking the button, as you can see, the red LED lights up and appears, a symbol that indicates indeed the emission of a sound on the monotone buzzer. Because we are using an active type buzzer, so we proceed to replicate the circuit on our board, taking the active buzzer, which is the one sealed hermetically facing downwards. We place it on the breadboard. We take power and ground from the board and connect them to the breadboard. We set up an LED that can light up together with the buzzer. So we place them on the same row. Then I connect the end of the resistor that powers the LED, the anode, with the positive of the buzzer. In this way, by powering a single row, we will power both the LED and the buzzer. Then, we also take a button. To activate the circuit, the button then directly takes 5 volts from one side, which we refer to as ground. In this way, bringing one end, we place it, let's say, on the same side of the button, thus already connected to the 5 volts. So at this point, we will have a stable electrical potential of 5 volts, referred to ground through this 1K resistor. The other part of the button, which is the one that will activate, we said the button is pin number 7. We chose pin number 7. The output that powers both the anode and the LED, as well as the buzzer is 8. And we placed it here. Let's verify for a moment. The connections ground and power brought to the breadboard, the 5 volts set as a reference on the button on the side. At the bottom, when I press the button, this voltage transfers to pin number 7. We read the state of pin number 7 when it is high. We power this wire that I used, in this case orange, which will go to power both the buzzer and the cathode. I forgot the 2 grounds, both of the LED. So the cathode of the LED obviously goes to ground. And the negative, be careful, because the shape of the circular device covers the pins a bit, so check carefully that you have inserted on the correct row, as the space between them is exactly 4 pins. Okay, so this is the negative of the buzzer. We power the board and prepare. And so the code that we previously created, we will now upload to the board. Upload completed. Let's verify the operation by pressing the button. So, indeed, when the button is pressed, the LED lights up and a single monotone sound is heard. This is because, being an active buzzer, when we power it, it can only produce this type of sound. Now let's see how to use the passive and multitone buzzer. As an exercise, the idea is to use 3 buttons, where each button will correspond to a different frequency. So, let's arrange the 3 buttons. Bring the ground to the breadboard. Also bring the 5 volts. Then refer the reference voltage to the side of the button. Copy this configuration since we need 3 identical ones. And bring them all over here. The buttons are ready. Let's use, for example, pins 5, 6 and 7 as the button inputs. Perfect. At this point, let's also connect the ground to the negative pole of the buzzer. And let's say we will power the buzzer. So the positive pole with the pin number 9. From a circuit perspective, we should be set, so we have 3 buttons. Ah no, of course the ground reference is missing. The resistors we are using with the buttons. So, by pressing the button, the potential on this side of the button, which is 5V, reference to ground through the resistor, is brought to the other side. And we intercept this high state of the button with input pins 5, 6 and 7. What do we need to do on pin 9? In this case, at the code level, we won't use digitalWrite because we are not interested in emitting a sound. However, if we go to the Arduino reference, we find a basic function called tone, a very simple function where we pass the pin we are powering and the frequency of the square wave to the function. Therefore, the buzzer will emit a sound at a different frequency. There is a third parameter that is not mandatory, but if we pass it, it is a number that represents the duration in milliseconds of the sound. So we will use the basic version. Let's try to write the code. So I defined the button 1, button 2 and button 3 in order 5, 6 and 7 on the corresponding pins. And then one that we call buzzer, it's 9, which is what we use to drive the cycle with the up tone function. First of all, we set the usual using the pin mode. We specify that these are input pins, which we use to monitor the digital input state of the buttons. While the buzzer is an output. Perfect. At this point, we go into the loop and we will use a series of if, else if, to monitor the three different states. As we do the first argument, which is a digital read of the first button, so of pin number 5. So if digital read button 1 is high, it means we are pressing the first button. So if this is happening, using the tone function, then tone, we review which pin should tone use. It is pin number 9, which is the buzzer. What frequency do we use? 440 Hertz, which is an A note. We set it in the comments, so double slash. So we know that 440 is an A note. After, if we know there's an else, in this case, it's convenient to use an else if, because else if allows us to put an otherwise if, meaning we can go on to say, okay, if 1 is not pressed, maybe 2 is pressed. So, else if we are pressing the second button, then we change the buzzer frequency. We set it to 294. If I'm not mistaken, it's a D note. So else if we are instead pressing the third button, then we go up a bit, 349, which is an F note. At this point, we've finished with the buttons, so that's fine. Else. So, if we are not pressing anything, we use another function called note on. Always based on Arduino. Obviously, we need to tell it who we are referring to, so we set the output of pin 9 to 0, ensuring that we are silencing the buzzer. We add, as usual, a small delay in the loop, just to provide some stability. Also for the simulator. First of all, let's check the code. To ensure I haven't made any spelling mistakes, everything seems fine, there are no syntax errors, and I upload the code and paste it. We start the simulation, and by pressing the various buttons, you see that the buzzer lights up. Obviously, for now, you don't hear any sound, but I assure you that the frequencies are different. At this point, let's take a look at the physical wiring.
Let's take the buzzer. Passive, so the one open underneath, to be clear. This also has a positive and a negative. This also has a pitch of 4 pins. The buzzer, we said we control it with pin number 9. So this one here. We need to set up 3 buttons. We already have one from the previous exercise. We have the resistors, referred to ground. We bring approximately 5 volts to each of the individual sides of the 3 respective buttons. In total, okay, with the buttons, we should be there. The 3 outputs, just so we don't forget, let's also put the negative of the buzzer to ground. And then we connect, as we said, the first button will be at 5. button at 5.
Which is this one? Second button. 6.
Third button to pin number 7. So let's check the connections. We have brought ground and 5 volts to the breadboard. The 5 volts are referred to the lower part of the buttons, and this potential is brought back to ground through 1K ohm resistors. The output of the buttons, therefore 5, 6 and 7, is intercepted by pins 5, 6 and 7 and the high state of 9, so specifically to the tone function it will send to this pin, thus to the positive of the passive buzzer, the function of a square wave with corresponding frequency. Let's try to transfer the code. Upload completed. Let's go check the button presses, which is happening. Depending on the button we press, the frequency is different, just as we set it based on the if-else-if structure, and therefore based on the different frequencies,